Hello and welcome to the lecture. So in this lecture we will be starting a new chapter, acids and bases. Now before looking at acids and bases there are many concepts regarding acids and bases which will help us to define actually what acids and bases really are. Now the first concept which was proposed in order to define acids and bases was Arrhenius concept of acids and bases. Now, according to Arrhenius, there are separate definition for acids and bases. Now, we have acids and we have bases. Now, according to Arrhenius, an acid is a substance and acid is a substance which gives hydrogen ions in aqueous solution. So this acidic and basic definition by Arrhenius concept, it is revolving around water. It is revolving around water. So this definition of acids and bases, it is applicable where there is water. So according to Arrhenius concept, an acid is a substance which gives hydrogen ion, which gives hydrogen ions in solution, in aqueous solution. So any substance is an acid which when dissolved in an aqueous solution, that will give hydrogen ion, that will be regarded as an acid, and that will be regarded as an acid. Similarly, according to Arrhenius concept, a substance which gives hydroxide ion, which gives hydroxide ions in aqueous solution, so that will be a base. Let us understand this Arrhenius concept of acids and bases by using certain examples. So first of all, let us take an example of HF. It is hydrogen fluoride. So if I put this substance in aqueous solution, so what happens is that H positive plus F negative will be generated. So since in aqueous solution we are getting H positive ions, so according to Arrhenius concept of acids and bases, any substance which will give hydrogen ion in aqueous solution, that will be an acid. So HF, this is an acid in aqueous solution. This is an acid in aqueous solution. Why? Because it gave proton when dissolved in an aqueous solution. So similarly, suppose we have sodium hydroxide. So when I put this sodium hydroxide in aqueous solution, it will give Na positive plus OH negative. Now this sodium hydroxide when dissolved in aqueous solution, it gave hydroxide ion. So any substance according to Arrhenius which gives hydroxide ion in aqueous solution, that will give Arrhenius sodium hydroxide. It acts as a base. Why? Because when dissolved in an aqueous solution, it gives hydroxide ion. So sodium hydroxide, it will act as a base. So this was all about Arrhenius concepts of acids and bases, which is based on that any substance which when dissolved in an aqueous solution, if it gives hydrogen ion, it will be considered as an acid, and any substance which in an aqueous solution it gives hydroxide ion, that will be considered as base. Now there is another concept of acid and base that is called as Bronsted-Lowry Bronsted acidity. It is also called as Bronsted-Lowry concept. Bronsted-Lowry concept. So this is called as Bronsted-Lowry acid-base concept. Now, according to this definition, a Bronsted acid is a proton donor. So, according to Bronsted-Lowry acid-base concept, a Bronsted acid, it is a proton donor, and a Bronsted base, it is a proton acceptor. Or we can say this is a substance, this is acid, and this is the definition of base. So, according to Bronsted-Lowry concept of acid and bases, a substance which has a tendency to lose hydrogen ion, or we can say that a substance which have a tendency to donate proton, that will be considered as an acid, and a substance which has the capacity to gain a hydrogen ion, or we can say that a substance having the capacity to accept a proton, that is considered as a base according to Bronsted-Lowry acid concept. Now, let us take certain examples so that we can fully understand this concept. So, first of all, let us take hydrogen fluoride. So, hydrogen fluoride. So, when it is dissolved in water, so it gives H3O positive hydronium ion plus F negative. Now here what happens is that HF, here we have HF. What this HF, it has donated a proton. It has donated a proton, and that donated proton, it is accepted by water. Accepted a proton. So we can say that HF, since it donated a proton, so according to Bronsted-Lowry acid definition, this will act as an acid. So this will be an acid. So similarly,